Welcome to the K-State Agronomy Composting Facility. So this is a state permitted facility with the state of Kansas, and what we compost here is waste grain, waste residue from experiments, and also from foundation seed production. We have some waste grain from that, and we also compost the food waste from the university, which is about 100,000 pounds a year, and we also compost about 100,000 pounds of greenhouse waste that comes from the Throckmorton Plant Sciences greenhouses. So when I say we're a permitted site, in the state of Kansas, anything over a ½ acre in site or anything that does source separated waste, like those things I mentioned, requires permitting. So that requires paperwork with the state, an inspection from the state quarterly, and also we have to have a set of plans. So what I'm standing on here, and this pad behind me, is a lime stabilized pad created by using quicklime and also water and then tillage and compaction to make a firm surface, so that even when it rains, we could get out here pretty quickly after the rain and do what we need to do with covering food waste or turning compost. I'll also note that our site is on a slope, so every good compost site you want to have a slope. You want to have a slope so that the water doesn't stand on the backside. You don't want it to be like a terrace system. You want it to actually run like this with the slope, so that the water runs down and into an infiltration pad area. We can't have any high strength wastewater leave our pad, so the green area there at the bottom of our site is designed to hold any runoff water and let it soak in after a rain and not leave and enter the waters of the state of Kansas, for example. So what I have in my hand is a thermometer. I'll show you some shots of this later probably, but this is a thermometer. So right now it's a beautiful day, about 80 degrees, and this thermometer is just registering the ambient air temperature. But this is an important tool in composting, and we're going to need to go put this in the pile. Because everybody always asks me, how do you know when compost is done? And what we do is use the thermometer to tell us that question. So here we are over at some different windrows, and this pile here that I'm going to stick this thermometer into has been turned one time. So what's happening right now is the microbes are actively breaking down the materials that are on the inside of this pile in the core. So anything on the outside, hardly anything is happening for breakdown on the outside, but what's the action is on the inside of this pile. So the outside air temperature right now is about 80 degrees, and yes, it's a black pile, but the heat that's showing up on this thermometer is really from the byproduct of the heat from the microbes doing their thing. So decomposing the compounds that are in here. So the greenhouse waste like plants and the grain and the food waste and the stover from the experiments, people's experiments, so grain, so corn stalks and wheat straw and everything else. So this is showing up to be maybe about 98 degrees or so, and I would want to take readings all the way through this windrow because it's pretty heterogeneous after just one mixing. So I would imagine if I'd stick this in several different places, I might get a higher reading. But since this says 100, that's not a very active composting temperature. At the height of its decomposition, we'll be seeing more like 140 degrees Fahrenheit. So it might be time to turn this compost, but maybe it's a little dry. So there's some things I need to tell you about. One of them is carbon to nitrogen ratio, and one of them is moisture content. So the ideal moisture content for composting is about 50%. You can compost in the range of 40 to 60% moisture, but 50% is perfect. So if I could just program it to the ideal moisture content, 50% is really good. At 50%, that means there's enough oxygen diffusing into the pile and carbon dioxide diffusing out of the pile. So there's enough void space for that to happen, but also that means there's enough moisture for the microbes to do their work. So the fact that my pile is only about 100 degrees Fahrenheit makes me think maybe it's too wet or too dry, a little too dry, which is a problem I sometimes have with my compost. With some of the things that I compost, like grain, for example, is a pretty dry product when I get it. Or maybe my carbon to nitrogen ratio is wrong. So an ideal carbon to nitrogen ratio is around 30 to 1. So if I were to design a blend of feedstocks to put in this pile to compost, if I could design it to be about 30 to 1, that would go really well. That would compost very nicely. Now if it's higher, so if it's higher like 40 or 50 parts carbon to nitrogen, then it might it'll still compost, but it might compost at a slower rate and my temperatures might not get that high. An alternative is if my carbon to nitrogen ratios were really high. So if I had really low, so if I had say 15 or 20 parts carbon for every 1 part nitrogen, it would rot kind of fast and we might have offensive smells. So 30 to 1, 30 parts carbon to 1 part nitrogen is kind of that perfect range. So I'm going to now pull this thermometer out of this side and move it over to this pile, which has been composted. It's been turned 2 times. So you can see that this pile looks a little more finished than this one I was just in. And the temperature is not as high either. So it's dropping down. In fact, it's coming down below 90 degrees Fahrenheit. So I think that means that I would want to check the moisture. And there are different ways you can check moisture. One way is to just dig in there and get a fresh spot and feel it. And so 50% moisture by feel might be, you'd squeeze it, and if you could just barely squeeze a little drop of water out of your hand, that would be about 50% moisture. But there are also methods for taking a known mass of a sample and drying it either in an oven or in a microwave oven. You can do this by microwaving a known amount of compost, so maybe 50 grams of compost, microwave it for, I usually do it about a minute at a time, so you don't want to burn it. You know how you can burn popcorn if you microwave it too long and then it tastes gross? Well, you're also burning out some of the carbon in the popcorn, and I don't want to do that. I only want to evaporate the moisture. I don't want to burn out the carbon. So yeah, this pile is about 80 degrees. Now I know it's not done yet, and visually I can also tell that. I can tell that because I've got stuff. And that stuff is just, it happens to be on the outside. I know that I need to turn this one more time so that everything that was on the outside can spend some time on the inside at the heart of the pile. So this pile is going to require at least 1 or maybe 2 more turns to get it all the way finished. So speaking of finished, another reason, besides the temperature and besides the appearance, there's another way you can check for doneness of compost. So I can smell it and I could dig in, and once you get to that point where the material smells earthy, it doesn't have any kind of offensive smell anymore, no high, not a high strong like ammonia smell to it, I would know it's done. And another way we can do this is by using what's called a Solvita test. So a Solvita test is a kit that you can get from Woods End Laboratory in Maine, and it's a way you can put compost in a jar, fill it to the line on the cup, and after 4 hours you can check and see how much carbon dioxide and how much ammonia is coming off. And the way you do that is with these little paddles that you stick in. So one is a carbon dioxide paddle and the other is an ammonia paddle. So you put those paddles in there, they're color indicators, screw it shut, and then take those paddles out after 4 hours and see how they look on the charts. So, and there's a matrix that comes with that tells you how to interpret those. But basically, once compost is nearly done, or even mature compost, they're not going to be giving off much ammonia anymore because most of that material has been broken down, but it'll still be giving off some carbon dioxide, but not real high levels of carbon dioxide. Because basically I think of it as like, once I've gone to the grocery store, right after you go to the grocery store, you know how there's all the good junk food in the house, all the good stuff to eat, and there's lots of activity, and my kids will, literally take the snacks out of my grocery bags as I'm trying to get in the house. But you know how like after a week or so you're like, oh, there's nothing good in the house, somebody needs to go grocery shopping, or let's go out to eat. That's kind of how it is once compost gets nearly finished. The activity of the microbes goes down, as indicated by low temperatures, as indicated by the fact that there's not a lot of carbon dioxide coming off anymore. And also, again, the goodies are gone. You can't smell the ammonia. We don't think ammonia is very good, but microorganisms like to break down those nitrogen compounds. So now I'm standing next to the most mature windrow of compost at the agronomy farm, and it doesn't smell bad. It doesn't smell like much of anything. One thing that we do have in our compost that might be a little unusual is we have a fairly large amount of soil because we compost material from the greenhouses, and so it might have a little higher density than some compost that you might buy at the store, for example. These little holes are here because we recently sent our compost off to be analyzed for its nutrient content. So this windrow and one or two more like it will be used by researchers this spring as they use our compost in experiments to supply the nutrients for growing crops. For a long-term corn project, or a long-term corn study, uses compost to supply nutrients. And it's also used in different landscaping projects around the university. So if they need to enhance the soil, they'll get some compost and use it in different plantings around the university. So we did send our samples off to a laboratory and get it analyzed. So what I do is I send it to a laboratory and we get a manure analysis. So just like you might do for any other kind of manure, getting it analyzed like manure, compost analyzed like manure, is a good thing to do because it is higher in carbon and nitrogen, so you'll want to get those levels tested properly. And so each year I know that on average my compost comes out as about 10 pounds of available nitrogen per ton of compost, which you think a ton of compost, well, that's per acre. So if you applied 1 ton of compost across a whole acre, so 43,560 square feet, that wouldn't look like much. 10 tons per acre is a fairly common application rate that you might use for compost in the field. Let's see, the temperature here on this one, well, that's interesting. It's only about 50 degrees Fahrenheit, so even lower than ambient there on the inside of the core. But it's 80 degrees now, but it's been pretty cool some of these mornings. So yeah, it must be, just hasn't, the whole thing hasn't warmed up to the 80 degrees ambient air temperature yet, I guess. But it's cold, means it's done. You know, it's not, the microbes aren't doing anything. The microbes are, you know, completely unexcited about the groceries in this pile now. It's boring, it's broken down, it's stable carbon and nitrogen compounds. Yes, so plastic. Plastic is the bane of any composter's life, basically. Plastic is everywhere. There's also little bits, here's like a lid off of a dressing container or something. Here's a steak out of a pot. We deal with a lot of plastic. Plastic is annoying and it's not very pretty to look at, but it's not as bad as glass. Glass is even worse because of course it's hazardous if somebody were to cut themselves on it. Metal is also annoying. If a commercial composting facility, if we were going to sell this to somebody, I would run it through a screen first, and usually the screens will have magnets on them, so the magnets are obviously going to take out any metal, nails, or, you know, we don't do too much yard waste here. We do a little bit of yard waste, but most of the leaves and grass from campus are just mulched in. They don't collect those up unless it's right around the front door of a building or something. But you know, if you were to rake a bunch of yards, you might pick up some nails from construction or something. But yeah, plastic is quite annoying. We do have, I don't think this is one of them, it doesn't feel right, but we do use compostable plastic bags in the dining facilities because it makes their work easier to have. They use them as liners, but they're very thin and they're like a light green color compostable plastic, and we don't see those after about 1 or 2 turns. So they'll be flapping out of our pile over there where we've turned it only 1 time, but after about 2 turns, after it's spent time inside the core of the pile, some real good time inside the core of the pile, we don't see it, it'll break down. So the compostable plastic can break down in a commercial size facility, and by commercial I mean where you have windrows that are a nice big size, so it's all about the core. The real action is happening on the inside of the pile. So this area is our drop-off area, and we use these dumpsters for containing the food waste. So food waste is brought out about every other day during the semester by the K-State facilities. So the custodial staff go around, collect it from all the dining facilities and bring it out here, and they put it in these dumpsters so that we have it covered properly. So as part of our permit from the state of Kansas, we're not allowed to leave food waste uncovered because it could attract animals or could attract flies, and we don't want that. So we cover it with the dumpsters so that nothing can get into it. And then as soon as we're ready to put it into our pile, our technician at the farm will come and take the food waste. He'll also take scoops of this new material over here, so this new grain waste and new stover and new greenhouse waste and things like that. He'll take it and mix it and combine it to make a windrow out of it. So that's our goal, is to always keep it covered. Those are called vectors, so insects or coyotes or anything else, those could be called vectors. If they're a thing that could spread disease around, which we don't want mosquitoes either standing around or flying around, but we need to keep our vectors, we need to have proper vector control is what that's called. So can I show you the equipment next? So this is one of the pieces of equipment that we use. It's called a turner, a compost turner. And so basically it kind of reminds me of a manure spreader. There's this bar here, and its job is to violently beat and turn and mix the compost. So everything that was once on the outside will end up on the inside of the core. You can see it's a place where plastic gathers quite nicely. So periodically we'll go and we'll cut all the plastic off of that and throw it away. But it is sort of a, you know, the plastic is an annoyance in compost. This is one of the compostable bags that we use with the dining services, and it's very thin. It's just a liner style trash bag. It's not meant to be a big, you know, like stiff or sturdy trash bag. It's meant to help the food waste slide out of these large barrels that they collected in easier. So this is compostable on the inside of a big windrow, but it doesn't compost very well. Most plastic doesn't compost that well in a backyard setting unless you really have a large, you know, at least, you know, 3 by 3 by 3 sort of foot volume of compost.